So, how did everybody feel about the stuff we went over last night?
Pretty good. I'm going right now. Oh, you mean like the aircraft systems and all?
Yeah,
It's actually very interesting to know what goes into starting an aircraft and what's what, like what does what on an aircraft.
yeah,
I never thought that the because I think from yesterday I heard that the both engines are separated, are both operated by different, what do you call it, hydraulic switches. Um, and Usually, I would assume that just turning on an hydraulic switch would control the two engines. Or we get kind of confused here, but do you know what I'm kind of talking about? Like
talking about the
the four
FADEC,
hydraulic buttons. Yeah, yeah,
not
like
the
the
hydraulics,
2A,
but the
3A.
FADEC. Oh, the pumps that actuate the
Yeah, that's what I'm trying
controls.
to say. Yeah,
Yeah,
Hey
yeah, I'm getting
Garrett,
a little confused with that, but
yeah. What's going on?
um, I couldn't find the last night's class on YouTube. I'm
Um,
wondering if,
yeah, I had forgot to put it on the YouTube page, so we have to convert it and everything, and then once we convert it and it like shows up as a file on our computer, then we have to go and add it to YouTube. I just barely got it up.
oh, okay. Yeah, I
So,
was just curious because I was just looking for it and I was like, they usually get them up really early, so
yeah, I
yeah.
usually have them up the same night, but um, yeah, last night I was pretty exhausted. I like converted the recording. As soon as I clicked that button, I hit the sack. I was tired. so, so sorry
Yeah,
about
no
that.
worries, no worries.
Um, all right. Well, have you guys looked at the lesson plans and looked at any of the stuff that we put into those, or because we're putting video links and the PowerPoints and stuff into those folders as well. And so just letting you guys know that all that material is available for you guys that we go over. Um,
okay.
but um, just pulling up the PowerPoint here. Um, so yesterday we talked about um, systems on the aircraft, and today we're going to talk about um, MELs, or things that affect our flight operations when systems go down. Um, like I said before, the MEL list is basically a list of parts that can fail on the aircraft and what our requirements are to keep the aircraft airborne if something does fail, or if it's an issue that just basically completely takes the aircraft out of service. So we can fly with, one of those IDGs, if you guys remember what those are. You can fly with one of those not operating, but that's the main source of power, right? Um, but if that happens, then basically we have a certain amount of time we have to get it fixed, and then uh, on the flights that we do operate while that IDG is out of service, um, we have to run the APU continuously. So things like that. Kind of interesting that something so major can go wrong with the airplane, but we can still continue to operate. Um, So there's certain penalties that affect primarily us dispatchers as far as these failures go. There's times where we actually have to apply something or adjust our flight planning in order to compensate for the failures. So um, they kind of separate them into two lists of things. Is it passenger comfort, or is it safety of flight issues? So for bleed air, we talked about this yesterday. It's used for pressurization and anti-ice. We when you turn the bleed air systems on, it's like we said yesterday. It's taking that um, air that's flowing around the engine off the engine. So when that happens, we have a loss of thrust. The engine doesn't produce as much thrust because we're pulling that air off to power those systems. So the importance of that bleed air is that when we turn the anti-ice on, which preventing ice from adhering to the aircraft is a good thing, but it also affects our takeoff roll. We take a weight penalty for it. And we also have altitude restrictions, no icing if it goes out. So it's a pretty bad scenario when those pneumatic systems and the bleed air systems go out of service. The APU, as we talked about yesterday, it's that self-contained turbine. And it provides that backup power. It also provides that AC and electricity on the ground. So, the crew and the passengers aren't cooking on the plane while we're waiting for takeoff. And it also provides that backup bleed air that we need. But when our APU is deferred, there's a possible weight penalty. If we go to an airport, we kind of hit on this yesterday. If we go to an airport and the pilot shuts the engine down, we have to use a GPU or a start cart to turn the engine back on, turn the aircraft back on. And then the other thing that we avoid when that APU is deferred is we don't dispatch to hot airports because, like we said before, if an APU goes out on the ground, we don't have that backup power, but we also don't have the air conditioning on the ground. So it's a pretty bad day if you're in Phoenix and it's 115 outside and you don't have that AC running on the passengers. So the AC packs, once again, they provide that pressurization in the AC kits. The bleed air is routed to the pack and removes the water, and then it provides that AC and pressurization centralized in the pack. One pack can basically take over if there is a pack deferred, but if there is one pack deferred, that restricts the altitude that we can fly up to. So we'll take performance penalties, we'll take fuel penalties, basically performance kind of equals fuel, right? If we're flying down at flight level 200 instead of flight level 320, It's a huge performance hit. So we're going to be burning a lot more fuel down low. And then, like it says, the air conditioning's not as effective. But basically, if both are deferred, we can't. We can still operate the flight, but you'd have to stay unpressurized below 10,000 feet, which really isn't doable. So typically, those flights are canceled. So the CIS, or the continuous ignition system, ensures the engine will provide that continuous power if turbulent or icing. If it's deferred, basically we can't go into turbulence or icing, known turbulence or icing. So pretty bad day. So as far as the electrical goes, like I said before, the IDG, integrated drive generators, we always have to have at least one. There always has to be at least one working. So that's pretty important. When one is deferred, the APU has to continuously run in flight to help manage the electricity load. We take a huge performance penalty, and there's an altitude restriction. For the 200s, it basically restricts us to we can't start it. I think it's any higher than 31,000 feet or 29,000 feet. I can't remember. And then we have to fly it like 25,000 feet once it's on. So if we have an IDG failure in flight, then they got to get down to that 25,000 foot mark, or else we get additional failures on top of that. So APU, IDG, pretty important parts of the aircraft. So as far as the fuel system, if that center or that single point pressure, so if that single point refueling mechanism is deferred, which it can be, like we said yesterday, you have to do over the wing fueling, and you need qualified people to do that. You need ladders, things like that. So some airports don't necessarily carry all of that stuff, and you need to make sure that we're equipped to refuel the aircraft if there is a deferred single point refueling system. And then, like we said before, you can't fill the center tank if that single point refueling valve is deferred. So we take fuel penalties in that case. Let's see. We can have navigation equipment, other equipment in the cockpit deferred. Here's kind of the penalties. So for our weather radar, we can't dispatch into thunderstorms or hazardous weather. If our FMS is deferred, we can't use GPS, which means no RNAV routes, no GPS, navigation at all. If our autopilot is deferred, we can't go up into RVSM. So what would be our flight level restriction if our RVSM's out? Or if our autopilot's out?
Okay.
Would it be 2,000 feet?
No. So RVSM, what's the flight levels RVSM's?
Flight level 90.
29 to 41,000.
So that's the flight levels that RVSM is. Those are the only flight levels that you can do that is considered RVSM, right? So where would we have to be if our autopilot's out?
28,000.
Yeah. So it restricts us to 28,000 feet because as soon as we hit 29,000 feet, we're in that RVSM airspace. And we have to have that 1,000-foot separation. So if our VHF radios are out, it requires 2 for dispatch. So basically, if VHF goes out, there's how many systems did we say were in the aircraft as far as those radios go?
Isn't there 2 to 3 of each?
So there's 3 VHF radios. One is the ACARS. Transmits on one of those VHF radios. So if if one of the radios goes down, they can use the ACARS for that second radio. But it defers our ACARS system. So the JIP was no takeoff or landing known in forecast wind shear. Known or forecast wind shear. So how do we know if weather's currently happening? We haven't gone over this. I'm just trying to figure out if anybody knows.
METAR?
Okay, METAR. That's one way.
The weather radar displayed on your map in the airplane.
So it's the weather radar will show us like convective or it'll give us like returns on clouds and stuff, but it's not really telling us if there's turbulence or wind shear. It's just saying, hey, there's a cloud right here. So
What about PIREPs?
PIREPs. You're the winner. There we go. PIREPs are reports that are written by pilots that we use. If we were to have a JIPWIS deferred, we could use a PIREP. So we'll look at SIGMETs and SIGMETs and convective SIGMETs and see if there's any forecasted turbulence, wind shear, anything like that. But then to actually see and dig down and see if it's currently occurring, not just being forecast. We'll use PIREPs to basically, figure out whether it's actually happening or if it's just like a warning. This could happen in this time period. So, and the same with weather radar. We can see weather on our computers, but yeah. But if there's like turbulence, no turbulence or no icing, we can actually go in and read PIREPs and figure out if it's actually occurring. So, what about a TCAS? Can we fly in RVSM airspace without TCAS?
No.
What is TCAS again?
Traffic collision avoidance system.
So we're flying 1,000 feet apart. Is that pretty scary? Thinking that.
So it's recommended. Or sorry, not recommended. It's required.
So it's not required.
Oh.
It's one of those things that pilots will frequently question the dispatcher on. They'll say, "Hey, my TCAS is deferred. I can't fly into this. I can't fly to 31,000 feet." You can say, "Yes, you can. TCAS isn't required for RVSM airspace. You just have to have air traffic control give you separation." So we advise ATC that this aircraft doesn't have TCAS and that they need to watch them and provide that separation, and that we're good to go. So kind of interesting. DME, we require 1 for dispatch. All right. So let's see. So now we're going to kind of take a look at this MEL CDL manual. What's a CDL? Does anybody know?
Can't remember.
Jordan, do you know what a CDL is?
I don't think so. I thought it was a license to drive a semi truck.
Close. You're not wrong in that answer. There we go. Evan's got it. Configuration deviation list. So basically it's telling us what can be missing. So an MEL is a minimum equipment list, which tells us, if this isn't operating, this has to be working. A configuration deviation list means that, say there's something structural with the aircraft, or there's seals, certain seals that need to be on the aircraft. A configuration deviation says, there's this many seals that are allowed to be missing out of this many, and if that happens, then you have to take a weight penalty here, or things of that nature. So they're different but similar in the sense of telling us when we can and can't fly. So when we pull this up, and we're going to keep this in the lesson plans here, like I said before, the CRJ 700 equipment type and the way you'll see it in most of the manuals is the CL 600 2C10. The CL 600 2D 24 is the 900, but they're very similar aircraft in almost every single way. There's just minor differences between the two. So we can use this manual for both aircraft, basically. This is kind of goes through. This is when you're doing dispatch. This is going to be one of your favorite parts of every book, is this index, and it tells us what chapters cover which parts of the aircraft. The ones that we highlighted here are 90% of the time going to be the ones that when we start flight planning, if we give you guys an MEL, these are the chapters that you'd go to find those MELs. So when we start flight planning, you guys will become very familiar with this manual. And on your practical test, a lot of times, it depends, but you could be given any one of these any list of problems, and basically you have to make sure you apply them, because if you don't apply the MELs and correct, then that's a FAR violation, and basically could mean an automatic fail. It just depends on what it is. Not to scare anybody. You guys will be so good at flight planning that it won't be a problem. But so this just kind of goes over an explanation of the format of the MELs. We're going to go over this. So the system numbers, or MEL block, are based on the ATA specification number and numbered sequentially. Kind of common sense. If there is a bold Cat 2 in the box with the item deferral list of the system, it also requires us to downgrade from a Cat 2 status. So this doesn't apply to you guys as much because we won't be doing Cat 2 approaches, planning for Cat 2 approaches in this class. But basically what it's saying is that if there's a Cat 2 in bold letters on the MEL box, then there's a penalty or a restriction that basically means that we can't do our Cat 2 approach. And the same thing goes with RVSM. So if you see an RVSM or a Cat 2 on the MEL, that means that you won't be able to fly that approach or fly in RVSM airspace. So just kind of skim through this. So the required block is the minimum number of items required for the operation provided, and the conditions specified in the remarks exceptions are met. So we're going to take a look at some of these blocks, but basically all this one is saying is that if there's multiple systems on the aircraft, like 2 IDGs, it will notate how many of them have to be working in order to be legal to dispatch. There's a remarks or exceptions block that includes a statement of either prohibiting or permitting operation with the specific numbers of items inoperative, provisions for such operation, and appropriate notes. So basically it's saying that there's a block that we'll see that it will tell us, what maintenance has to do, basically, in order to keep the aircraft operating, whether that's, put a tag on something, or, if it's a seat, then, basically put a sign on the seat that says don't sit here, or whatever it is. So placarding, it also has a placarding box that we'll see, and it'll tell the maintenance people what sign, what form they have to use in order to indicate that the item isn't working. So yeah, this just kind of goes over the maintenance steps as far as placarding and CDL steps. So not too pertinent to what we do. So anyways, this is what the MELs look like. So here we see the MEL number 21-23-1. The item is the affected part of the aircraft. The category indicates how severe, or it basically is telling us, this is, really bad, or okay, this is that instrument box. This tells us how many of each one of these instruments or items are on the aircraft, and this tells us how many are required to operate the aircraft. This remarks and exceptions section here, it tells us basically what has to happen in order to fly, or what the penalties are. Placarding tells the maintenance crew what they have to do, what sign has to be placed on specific panels. To indicate that the part's not working. This tells maintenance. The maintenance procedure, kind of self-explanatory. Basically just says, if this isn't operating, you need to go to this panel, this circuit breaker number, and this name, and you need to open the collar or open and color the circuit breaker that follows. So they basically have to pull that circuit breaker out and put something on there that won't allow the pilots to push it back in. So for this MEL. Operations procedures, this is where it'll tell us certain penalties or certain restrictions that the flight crew needs to follow in order to operate. So these are our MELs. We'll just kind of hit a couple of these MELs, take a look at them. Let's see. This one's kind of interesting. So these display cooling fans, these are for those PFD, MFDs. Some of the interesting things that happen is in the QRH, the pilot's operating handbook, or the quick reference handbook that the pilot carries with them. Basically, if one of these fans goes out on the back of the display, they have, I think they said 30 minutes to get the plane on the ground. Kind of interesting, because if one of those displays goes out, it's a pretty bad day. Pilot has to be able to see the instrumentation, right? Here's one that takes a penalty. So the automatic cabin pressurization controllers. As we can see here, you can see that, as we said before, there's penalties and certain things that we have to do. And it's going to be in this remarks and or exceptions box. So for us dispatchers, what we have to apply to the flight plan is basically operations are conducted unpressurized at or below 10,000 feet. So yeah, you can see the different operations, the things that we need to pay attention to as dispatchers, and because some of this directly affects how we plan our flight. Let's go down here to here's that air conditioning packs. Remember, there's two. One's required to be working. The altitude restriction. Operations are conducted at or below 31,000 feet. Let's see. Does anybody have any questions about these so far? You guys are seriously like the quietest class in the history of dispatch school.
My boyfriend usually comes home and takes a nap in the same room that I'm in, so I try to not be too loud.
You're fine.
Otherwise, I'm pretty talkative.
Let's see.
For me, it's just all new, so I'm just trying to take it in. That's
I
all
hear you. I hear you.
Yeah, what he said.
Here's an interesting one. So the cargo air, the valve, basically, um, that allows the airflow down into the cargo area. I believe that's what that's referring to. Yeah, the air conditioning. It allows the air conditioning down into the cargo bay. It basically says that if this isn't working, you can't carry animals down in that aft cargo compartment. So, autopilot. So we see this note here. RVSM autopilot is required for RVSM. You can see here that RVSM Cat 2 in big bold letters. So that's your first sign. Look, you need to pay attention to this MEL. But then we see this operation procedures as well. We can't do Cat 2 or RVSM, fly an RVSM without an autopilot system. The flight directors, once again, RVSM and Cat 2. So you see that here. The
Didn't
category
flight
B.
directors, sorry, is flight, well, I know the flight directors are always, they always have something to autopilot, but can't you also have flight directors manually flying?
Yeah, so the flight director is just that.
It's just a guidance thing.
So it's the flight directors are oh my gosh. So, well, you can see it here in this this operations procedure. Basically, the pilot controlling the aircraft has operative flight director. So he has to. The flight director is just that. Let's see. Um, oh my gosh, I'm struggling today, guys. Sorry, my brain's fried. It's almost the weekend.
I hear that.
So yeah, the flight director is that main display that the pilot is using to fly the airplane. So it's not only is the flight director like telling him where he is at and the pitch and the angle and the bank and everything like that, but your autopilot as well is controlled. Like that's how when they're setting their autopilot, and that's why it says right here, if a flight director is out, then the autopilot is considered inoperative. And that's because when they set the autopilot, that's what they're using to set the autopilot is on their display. There's little pink markers. I can pull up what a flight director looks like. So you can see here, let's make it big. If this is an operative, these pink markers are what the autopilot is set to. So if this display is broken, how is the pilot going to, have reference to that? Not only that, but look at how much information this is supplying the pilot. It's anybody that's flown like a Cessna or anything's probably flown what we call steam gauges, which are a flight director just in individual manual gauges. But this is giving all the pertinent information for the flight. This is our vertical speed indicator. This is our altimeter. This is our altimeter setting. Right. This is our trying to remember what it's called in the steam gauges. This is basically our attitude, situation, attitude. I can't remember what it's called for some reason right now. This is our speed. So this is our heading indicator. So I mean, this is quite a bit of information all in one little screen. Pretty bad if that goes out. Pilot has no references to where they're at. If one of these goes out, if the pilots goes out, well, if any one of the displays go out prior to takeoff, we can't even take off. Like we can't take off with that known issue. Once again, here's Cat 2 all by itself. Once again, the Cat 2 approach is not authorized. Yaw dampers. Category 2 is not authorized. So our ACARS. If the ACARS is deferred, then, like I said before, well, if one of our VHF radios goes out, we can use the ACARS system, the VHF radio that basically communicates our ACARS messages. Can use that. The pilots can use that, and if that happens, then the ACARS is deferred. And the way we would contact our pilots in that scenario would be with Delta radio is what we call it, or Atlanta radio. Then it also tells us that our off, on, out, in times have to be reported by the gate pretty much. So that's how we get our information. You guys have any questions about these so far?
Not yet.
No, sir.
So here's the IDGs. This says 320. I know that's changed. I know it's a lot lower than that now. That may be for the 200 though. So here's your APU. Your APU can go in op, but both IDGs have to be operative. That's pretty important. or air-driven generator. Just basically can't use the system. So, anyways. It's kind of interesting. This just goes through everything that all these MELs that, I mean, you can see how minor some of the stuff may seem, but like the flight attendant seat assembly, may seem minor, but there's a procedure that we have to follow if their seat is broken. So this tells us how to operate.
Just for application purposes, what's the most recent one you've seen at work that had a decent impact on you?
Me personally, I can't think of any, but you get MELs every single day. Had a MEL that the MEL was trying to remember. Can't remember the specifics of it. The MEL basically made it illegal to go, so you had to You have to swap aircraft at that point, or cancel the flight. And you have what are called system controllers, so that in the event that there is an MEL that takes a plane out of service, the system controller is kind of the one that's putting the puzzle together behind the scenes. Notify them and tell them that we need a swap, or if a swap is even possible, to keep the flight on schedule. Or
So just kind of back me up just a little bit. So how are you as a dispatcher first made aware of an MEL?
So when you go to plan the flight, you get a list of MELs. So on our computer system, when we go to plan the flight, it'll pop up and say, here are your MELs, and we can look at the MELs. The computer will assist with what it can. But our job is to make sure everything's, if the MEL is taking us out of service or whatever, it's our responsibility to make sure that MEL is applied. But yeah, our computer system just pops up and says, these are known issues with the aircraft. And then it's our job to look it up, look at the restrictions, and make sure that we're following the procedures that are required. The MELs are typically, the pilot will jump in the aircraft and he'll see a problem or something. If the pilot's, just starting out the day, he goes out to the jet and tries to, get the APU running or something, and the APU's not coming online, he'll call out maintenance. Maintenance will come out and check it out. And if maintenance says the APU's deferred, they write an MEL. They basically will write it down and send that information into the system, and then we have to apply it to our flight plan. So
a couple of days ago, we had a plane that had they had an air conditioning issue or they needed an air start and a GPU at the same time. So I guess I just asked the pilot. I'm like, "Are you using your MEL?" And look, yep. So I guess it was just on those
Yeah.
two things.
Yeah. So I mean, whenever we have like the bleed system or say, the APU is out, there's multiple problems that it can be, but basically if the aircraft gets turned off and the APU won't come online, or because that APU provides the bleed air for startup, right? So say that's not coming online. The only way to start the aircraft is both the air start and the GPU. So you have to hook it up to power and air and get that turbine spinning, and then fire it up. So that's the only way to get the aircraft started, and it's it can be a problem. Say you fly an aircraft in there that has an APU deferred, and the pilot that's flying into the airport shuts off the engine. Well, if that airport doesn't have an air start or GPU, then that plane is stuck there, right? Until we can get maintenance there. Maintenance, if it's not a maintenance base, maintenance will have to or if we don't have maintenance at that facility, then we'll have to have maintenance go out and fix it to get the aircraft out of there. And then you got all these passengers that are stuck there, and you know it can get pretty messy pretty quick. So, good question though. Did that answer it, or?
Yeah, I was just wondering kind of that, how I'm going to be seeing that hit me. And then of course I can go to these and address it. But
Yeah, so let me see. I'm gonna pull up a flight plan here. Don't. This will be an actual flight plan that we could possibly do. Let me find one. Okay. So, the way we'll do it in this class, as far as the flight planning goes and applying these things, what we'll do is we'll give you a packet, the route briefing packet. It'll give you an aircraft number, how many people are on board, how many bags are on board. It'll give you an estimated time of departure. And then if there's MELs, it'll give you an MEL number here. The way we'd apply that is we'd go to this MEL packet. Let's see, 3022.1. We'd scroll to that 3022.1 and find that. We're getting there. Might be there sometime later tonight, I guess. Let's see. Okay. 3022.1. So this says that the engine KEL and anti-ice SOVs are out of service. The aircraft is not, so we can't operate this aircraft in known or forecast icing conditions. Okay. So at that point, we go to our weather chart We can go, to our SIGMATs. We can look at an icing SIGMAT. Let's see. Come on, there's going to be some icing somewhere. There you go. So say we had an icing SIGMAT. This is kind of what it looks like. But we were flying Salt Lake to LA. We had a big old icing SIGMAT here. We'd have to route all the way around it. Some way in order to get that aircraft there. Or say, at the airport, at Salt Lake International Airport, the requirement for icing, for possible ice would be 10 degrees Celsius and visible precipitation. So what's visible precipitation? Anyone?
I'm not sure what you mean by the question.
Rain, snow.
Rain, snow. What does it come from? What do those types of precipitation come from? Clouds. Yeah. That's visible precipitation, right? So,
hey, Garrett, those are my kind of questions. You keep those coming.
So yeah, like, say you have an overcast ceiling, 5,000 feet off the Salt Lake International Airport, and it's 7 degrees Celsius outside. Known icing conditions. That's possible icing, right? And if it's possible icing, if we have cloud cover over Salt Lake at a low level, the pilot can't, dodge the clouds, fly through them, whatever. We can't operate that flight. That takes us out of business, right? So that's the way we would see the MELs, and that's how we would apply it. So, does that help?
Yeah, thanks. Perfect.
Yeah. So it's a it's a daily thing that we'll see on our desk. Is there's a lot of aircraft that will have one problem or another, but we continue to operate them. We just have to make sure that those problems aren't something that affect our flight planning, or the performance of the aircraft. So let's see if I can scroll a little more quickly down here. Let's see if we get some CDLs. Here we go. Nope, still in. I don't know where the CDLs are supposed to start. There you go. So these are your CDLs. So this just kind of goes over our general limitations. So the CDL contains additional limitations for operation without certain secondary airframe or nacelle parts. The limitation in flight in the AFM are applicable except as amended in this appendix. The associated limitations must be listed or placarded on a placard affixed to the flight compartment on the instrument panel in clear view of both pilots. The pilot in command will be notified of each operation with a missing part. by listing the missing parts on the flight or dispatch release. The operator will list in the aircraft logbook an appropriate notation covering the missing parts of each flight. If an additional part is lost in flight, the airplane may not depart the airport at which it landed following this event until it again complies with the limitations of this appendix. This, of course, does not preclude any issuance of ferry permit to allow the airplane to be flown to a point where the necessary repairs or replacements can be made. So basically all that says is that in order to operate the flight, we have to make the pilots aware of it. Placarding has to be placed on the flight panel. We as dispatchers don't worry about that so much. That's in the PIC's hands because he's actually in the aircraft. And then we have to fly with the limitations. Now, if something happens in flight, we can't continue to operate that aircraft until it's once again been looked at and the proper limitations applied. We can't even ferry the aircraft. Ferry is where we, say we land a plane in Liberal, Kansas, and there's no maintenance there, right? It's just a little podunk, middle of nowhere town, but we have something go wrong with the aircraft. We can't even fly that aircraft to a maintenance base like Denver until it's been looked at and we've applied the proper limitations to the aircraft. Even though when we do these ferry flights, there's no passengers on board, it's only crew. So it's kind of important that we, make sure that the pilots are aware of the issues and that we apply these limitations. But here's kind of an interesting part of the CDLs. When a performance penalty, or where performance penalties are listed as negligible, no more than 3 negligible items may be missing for takeoff unless the following performance penalty is applied. When more than 3 negligible items are missing, the performance penalty of 100 pounds must be applied for takeoff, en route, and landing for each additional negligible item. So some of these CDLs, let's see if we can find one really quick. It'll tell us a weight penalty that we have to apply to the aircraft. If it's listed as a negligible penalty. So here's the sills that I was talking about. We have to take off weight in the account that a certain number of sills are missing. We have to take off 40 pounds for our climb, and we've got to follow this. So our fuel consumption goes up by 0.3%. So these are the penalties that we have to apply. But if it says like negligible here, we can only have 3 of those and still have no weight penalties. As soon as we get a 4th one, even if it says negligible there, that 4th one, we take a 100-pound weight penalty. The 5th one, we take a 100-pound weight penalty. The 6th one, we take another 100-pound penalty. The 7th one, we take another one. So it can add up pretty quick, I personally, rather than having a 100-pound weight hit, I'd like to take 100 pounds in fuel, or another person on the plane. So let's see if I can find one that says negligible. So the CDLs apply to the configuration of the aircraft, like the the outside of the aircraft, the important parts of the airframe. So let's see. There's got to be one. See how it says like even 10 pounds. Even if we had 3 that, it's like a no weight hit, taking 100-pound penalty is pretty bad. So here, any number or combination may be missing with no performance penalty. If we're missing 4 of those, we start taking 100-pound hits every one. So the first 3 are free. Anyways, this manual will go through. I don't think we'll have you guys apply any of these CDLs to your flight planning. Just kind of important to know what they are. More for future knowledge. You guys have any questions so far?
So when you said just a second ago, so you would sometimes have to either accommodate a passenger versus fuel versus just kind of weight. So you would have, like, you wouldn't be able to add a total of the passenger and the fuel, or do you know what I mean?
Well, all I'm saying is that, if these CDLs, they add up pretty quickly, and if we get enough of these CDLs, if we take 300, 400 pounds of CDL penalties, weight hits, for missing seals or missing screws or things like that, that all adds up really quick, and we start bumping passengers if it gets too bad.
Okay.
And me personally, I'd rather be able to apply those weight penalties to fuel and passengers than just taking weight hits because the seal's missing. So, hey, Adam's on. Adam, I'm sure you have something to say about MELs and CDLs. He's probably not listening. He's Mr. Fun Killer now. He went to the dark side and joined the FAA. But
That's something my mom always says. She's always like, I always tell her something about the FAA, and she's always like, oh, those B words, just like, just relating to my situation.
Yeah. Now the FAA's, I haven't met a real jerk of an FAA guy yet. So, and Adam definitely is not that way. So.
Oh yeah, I know a couple people who are in the FAA that are really nice guys.
Yeah, I haven't met one that was mean. So I know they're out there though. But it's the same with any job, right?
Just protocol.
Yeah. Anyways, so let's see. So do you guys understand what these are? Basically, it's really important that we apply these necessary, limitations or penalties to the aircraft because they directly affect our, weight and our flight, our performance of the aircraft, and we really got to pay attention to these MELs. If we miss MEL that tells us that we automatically require an alternate, or we can't fly into RVSM airspace, and we plan the flight at 31,000 feet, and the pilot misses it, we miss it. That's a FAR violation, and like I said before, those fines can add up really quick. People lose their licenses over missing things like that. So.
Yeah, and I wouldn't want to be the guy that breaks, like you said the other day, 18 different FAR violations in one day.
Well, that was in, yeah. That wasn't even in one day. That was pretty quick. So yeah. Well, let's take a break. There he is. You there, Adam?
Yeah, can you hear me?
Yeah. You hear us bad mouthing UFAA guys? No, just teasing.
Hey, it's I even badmouth us. It's one of those things. If you can't beat them, join them.
That's right. It pays off in the end.
Yep.
Hey, Adam, you're not quite on board with the new job. You keep talking about them and realize, wait, I'm one of
them. Yeah. What's funny about it is they always get such a bad rap because they've had kind of this for a lot, over the years. I mean, and it's warranted, kind of the sentiment that people in the airlines have towards the FAA, because over the years they have established kind of a precedent for, their enforcement rules and the way they go about doing things. But they actually, so ever since I got into the FAA, I've kind of been learning and seeing. Apparently, a couple of years ago, they came out with this new, like, nicer, softer FAA mentality that or approach that they're supposed to be using with the airlines, or of anybody in aviation for that matter. But they've got this new thing. It's like enforcement is the last option. Like this whole mentality about how they're supposed to be nicer and supposed to collaborate and try to help people stay in compliance. And anyway, that's actually, I'm in Oklahoma City right now at the FAA Academy. I'll be here for I'll be here until March 14th. So 6 weeks of just pumping me full of this stuff here that they're trying to get out onto the, teach all the inspectors this new mentality.
So the
FAA is now doing safe spaces too.
What? Sorry, say that again, Greg.
FAA is now providing safe spaces as well, in addition to universities.
I guess so, yeah.
So the FAA, we have a reporting, basically a reporting system at work now. It's been in place for a while, but we call it ASAP, and basically, as long as we're telling on ourselves and resolving the issue, and it's not like a consistent problem, there's no penalty that the FAA will take out on. Like, we don't get beat to death for, hey, I missed putting an alternate on the release. As long as we're reporting it and coming forward and being honest about it, basically the FAA can't come in and say, all right, and beat us up about it. Can't just walk in and take our license. I mean, if it's intentional, that kind of changes things, but if it's just an accident,
Yeah, that's kind of what I've been learning too, is that the FAA, so you're talking about the ASAP program, is what Garrett's specifically talking about. But he, the FAA, pretty much under no circumstances are they usually ever going to violate you for doing something, as long as you weren't, kind of like Garrett was saying, as long as you weren't intentionally doing it or intentionally trying to break a rule, or having a repeated behavior. So yeah, this ASAP program exists for dispatchers, pilots, and basically it's kind of one of those things where if you realize that you violated an FAR, and either you figure it out yourself, or even if somebody brings it up and says, "Hey, Adam, you just sent this release with an illegal alternate, or it needed an alternate and you didn't add it." But if the damage has already been done, then you have this option of filing an ASAP report, which protects your license. It guarantees that you will not have enforcement action taken against your dispatch license on behalf of the FAA. So they actually get the report sent. It's all de-identified and everything, so it's kind of cool. The airlines also have a similar program called VDRP. You'll learn more about that, later on. But it's kind of like an ASAP program. But yeah, there's a lot of different. You pretty much have to be wanting to get violated or wanting to, lose your license in order to actually have it done. I was talking to the FAA inspector that's over SkyWest. His name is Jeff Gilmer. He's been in the FAA for 15 years. He has taken 2 people's dispatch license in that entire 15 years, and both of them were because they came to work high on drugs. So it wasn't even for obviously, that's a rule. You gotta, can't do drugs and come and dispatch planes. However, that's the reason, though. That's the reason. It wasn't for anything else. I mean, it's kind of one of those misconceptions about the FAA, is that they're out to get you. They're really not. They're pretty much trying to work hand in hand. So it's one, like here, at UPS, the ones that I work with, they have a pretty good relationship with the FAA. So it's kind of, as when I became a dispatcher, I think I was introduced to it wrong, just because of the people that were at SkyWest at that time really had kind of a bad taste at the FAA, towards the FAA. So I don't know. I kind of started off on the wrong foot with them, but over the years I realized that they're just like any other person. You can shoot the breeze with them, and people act like they get all tense and get all stressed out when they're around, or if they're watching them do releases. You don't need to be. It's it shouldn't be like that at all.
Yeah, and it's kind of nice now. Back when I was doing my flight training, we were scared to death of the FAA. I grew up in that environment, with aviation, where it was like the FAA was out to get you kind of mentality, and it, I've seen it change, and it's not so much like that anymore. They're definitely trying to rebuild their reputation. So
I was doing a check ride, one of my check rides once, and I was so nervous with that examiner that I got to almost the top of my climb, and he said, "How's your arm?" And I said, "What do you mean?" I said, "Pretty tired?" And he said, "No, I'm doing okay." And he said, "Because your hand's getting kind of white." He kept going down this road, and I had no idea what he was talking about. And I forgot that I was so nervous with all the navigation that I forgot to trim the airplane. And he realized I was just about to rip the yoke out of the airplane trying to keep it trimmed. Rather than fail me, or cut me on the check ride, he was just like giving me every possible hint that, hey, grab that wheel and trim it out.
Yeah.
Yeah, and that's the way it should be. I mean, it should be, to the greatest extent possible. They should try and set a comfortable setting for you. But hey, I was talking to somebody today that was doing a cockpit en route inspection on an airline, and I think it was a Southwest 737 flight. But anyway, the first thing that they do when they get into the cockpit is they they tell them, hey, we're here. I'm doing an en route inspection. Just you do your normal thing, and I'll do mine. Don't feel uncomfortable or anything like that. Anyway, the first thing they do though is they ask to see their licenses. And with pilots, they have to have their license and their medical certificate with them. So they're supposed to get both of those things out. Well, come to realize the FO starts digging through his stuff and realizes he doesn't have his license or his medical on him at all. And kind of just became incredibly stressed out and started freaking out, like, thinking that he was going to get his license pulled and that he was, going to not be able to be a pilot anymore, all this and that, just the worst case scenario. Because that's what he grew up thinking. His tenure in the airline industry. That's what people train you to believe. But the FAA inspector started just talking. Well, he said, I don't have it on me. I can't find it anywhere. I think my kids were playing with it. And the FAA inspector says, well, do you have any alternate means of being able to, go and print out a temporary copy, anything like that? Basically, hinting towards the fact that he can go log on to the FAA website just from a computer and jump onto the Airman Certificate Registry site. And anybody can do this, a dispatcher, a pilot, anybody who has any sort of FAA certificate can jump onto this website and print off a temporary copy. And that'll serve the purpose of your license if you misplaced it or if you forgot it or anything like that. But it was a very simple fix. And yet the FO started to believe that it was doomsday. It was over. His career was over. Sweating bullets, freaking out. He didn't settle down until it was like a 4-hour flight, but it took him about 2 hours to actually settle down and then start having a normal conversation with the captain and the FAA guy. Just he just was so worked up over the whole thing that really over a non-issue. And it's just kind of goes to show you that they'll try and they'll obviously work with you, and they'll try and point you the right direction, and always try the last step is to take any sort of an enforcement action. And even at that, you have to just be doing something totally crazy and asking to have your license taken away. So it rarely ever happens, and it's kind of one of those things where you just need to just rest easy. It's kind of like we've been saying about when you take the practical exam for a dispatcher at the end of this course. Just feel comfortable. I mean, the examiner for that, I mean, he's not an FAA employee, but he represents the FAA technically in that position. But he's going to steer you the right direction. If you can't remember something that he asked you, he's going to point you the right direction, and he's going to try and fish it out of your memory. That's what all FAA people really should be trying to do. Not that you're not going to run into a bad apple here or there. I mean, they exist in every organization. So, but they unfortunately make the rest of us look bad.
Well, why don't we take a quick break? We'll kind of in there. Let's take 10 minutes. Or do you guys need your dinner break?
I can go out and make a sandwich in a matter of 5 minutes. So it's not really.
Yeah, 10's fine.
10's fine?
Mm-hmm.
Alrighty. 7:10, we'll be back on.
Are we gonna want to memorize what those are and what they?
The three that you need to memorize and remember for sure are those three: V1, VR, and V2. You will get asked questions about, what is V1 speed, what is V2 speed, what is VR. VR is pretty easy to remember. But yeah, you definitely need to know what the V1 and V2 speeds are for the test. And when I say that you need to know what they are, you need to have an understanding of what they are. But really, you just need to be able to say V1 is our takeoff decision speed, V2 is our takeoff safety speed. So And then let's talk about Group 1 and Group 2 aircraft. So when we talk about in the type of aircraft, say for like jump seating, basically we're talking about, is it a Group 1 aircraft or a Group 2 aircraft? Back in the day, the SkyWest used to fly the Brasilia, which is a turboprop aircraft, and that would be considered a Group 1 aircraft. And so back in the day when we were jump seating, you'd have to do 5 hours in a Brasilia and then 5 hours in a Group 2 or turbojet powered aircraft. So, which would be your CRJs. But now, since we only fly Group 2 aircraft, that's all that really matters. We kind of talked, like I said before, the video goes over the principles of flight pretty well. For those of you that are tuning in after the class and just watching this video, weren't able to make it tonight, just go into the page, into the Google Drive, and look at today's lesson plan. It'll have this video link in there, and watch it. But does anybody have any questions on the principles of flight? So
I can't say that.
So what principle of, or can anyone explain Bernoulli's? It talks about Bernoulli's law. Anybody want to take a stab at that?
The way I understood it was the air wants to stay traveling the same speed, but since it has to travel a longer direction on the top sap of the wing, it has to move faster, and the faster air creates a low pressure area, which provides lift.
Yeah. Perfect. So this is kind of a diagram of exactly what you said. So we got air moving over the top of the wing and down the bottom of the wing. So as the air travels over the top of the wing, it accelerates, creating that low pressure, and then that basically allows lift. We see this as well.
Do you want us to write the definition down?
I don't think you're actually asked the definition. I just want you guys to have a basic understanding of what it is. But yeah, this is a diagram of the wing. So when we talk about the wing, what's important kind of to remember, once again, you probably won't be asked any of these questions on a quiz or anything, but you won't be. But when we talk about the wing and the shape of the wing, everybody has seen the side profile of a wing, but we have certain reference lines that we got to remember when we talk about these wings and producing lift. So,
Okay.
so the relative wind, so wind's, coming at us head on, right? So to produce lift, we change the angle of attack, right? So we call this the leading edge of the wing, but we change that angle of attack, and that will help increase it. kind of helps increase the lift of the wing. Now, when we change that angle of attack too much, it'll start disrupting the flow of air over the top of the wing, and when that happens, we call that a stall. Basically, what will happen is the wind will come over the top of the wing here, and then it'll just kind of vortex or vortice off the end of the wing. So that's what a stall is. But I mean that's basically the principles of lift and how these wings work. Now that's going to be important when we're learning the aircraft because there's certain, when we talk about the engines and compressor stalls, we kind of talked about it yesterday. The blades inside our turbines are wings themselves, little individual wings, and when they stall, it creates, it'll mess you up, as we so lovingly decided is the technical term. But yeah, it'll basically stall out those turbine blades to where the engine just stops functioning. It's not producing that thrust anymore.
MU is the acronym. MU.
Yeah, exactly. But yeah, I mean it's the same with an aircraft. When we're flying an aircraft, the pilot has to know these certain speeds because it affects the performance of the aircraft and his ability to control the aircraft and to fly. When we talk about ice on a wing, it changes that shape of the wing enough to basically disrupt the flow of air over the wing, the smooth flow of air over the wing. So when that happens, it changes the aerodynamic profile of our aircraft to the point where the airplane doesn't want to fly anymore and falls out of the sky basically. So that kind of that video does a really good job of describing these principles and the general characteristics of the aircraft and what how it flies and everything. But it's a good review. Man, with that being said, we've kind of covered the CRJ pretty thoroughly. Let's see. Does everybody feel like, I don't know. I don't really know where to start with some of you because I know some of you don't really have an aviation background, so I don't know if you guys are grasping what we've been talking about as far as these systems in the aircraft. So I need to know, is this making sense to everybody? Does everybody feel comfortable so far? I know there's some of you that do. I get that. But
Hey Garrett.
yeah.
For me, there's just so much information. A lot of times it's hard for me to recognize what's like what I need to know, like for the quiz and stuff. So it always helps me when we do the quiz reviews because then I hone in on the information, then I can learn it. So I don't know, it might help to just be asked some of the questions that we're going to need to know so that we can kind of direct where we need to learn our stuff.
That's exactly what I was going to say too. Like, I don't have any sort of aviation background, so when there's a lot of information coming at me, I kind of hope, like, just the more I'm exposed to it, the more I'm going to pick up on. But it's nice, like, yeah, I had like quiz time. I can kind of narrow down like the important bits, I guess, like more of the stuff that I need to be focusing on, and that helps a lot. So,
Okay.
but I don't really know what I don't know.
Right.
So it's kind of hard to like, I don't know what
Right.
I'm not exposed to, I guess.
So I tried to tell you guys when we come up on the parts that are going to be in the quiz, I tell you guys to write things down. The other stuff that we talk about that kind of, just kind of comes off with it, all the information that we get on top of that is just secondary and supporting to those ideas that, I really try to focus on and try to hit hard. So we can go over some of the stuff that we
Garrett,
we'll be on the test. Yeah.
So, so with kind of like, if you guys remember back to day one, kind of setting the precedent, I guess, that kind of like the way you may feel like right now is completely normal and expected as far as we are concerned. It is a lot of information. There's, if you remember kind of me like giving the example of, there's all of this, you've got a whole, 2 tons of information, but you technically only need, just a small part of it that you actually need to, the things you need to memorize and retain, the things you absolutely need to know as a dispatcher. So there's the things that we're required to cover. And in addition to that, there's the things that, well, if you take the entire curriculum, I mean, there's a whole slew of stuff that we have to cover that, goes through the, the full 200 hours of instruction, all of the stuff you guys can see on the course outline is basically the FAA mandated material that we have to cover. A lot of this stuff that we talk about in here, this will literally be the only time you ever probably talk about it, and you may never ever hear about it again after this class. So take that part for what it is. As far as the relative practical dispatch part of this class, that a lot of that comes at the very, very end when we do the flight planning. The flight planning kind of ties everything in this course all together. It takes the systems, it takes the weather, it takes the FARs, all of the legal stuff that we went over in the first week. It takes all of the ATC, air traffic control stuff, the navigation stuff, all of it, because you got to use all of that at the very end in order to successfully flight plan. Now, if you kind of think about it this way, once you get to the last 2 weeks, although there is, some like new things that you do learn, the majority of it is really a review. And it's reviewed by way of putting it into practical application by doing the flight planning portion of the stuff. And that's honestly when a lot of stuff starts to click and make sense, because you're seeing it from the dispatcher's point of view, why it's relative to you as a dispatcher, why it makes sense, why you use it. And so part of this whole part, anything leading up to that, honestly requires just a lot of patience and kind of just a lot of just kind of bearing with it to get through a lot of the the mountains and mountains of information that we have to cover in order to abide by the FAA standards of the course. However, when we're telling you to write stuff down, or the stuff that you see on quizzes as an example, that's the stuff that really that you need to try and be memorizing. Once you get to the end of the course, you're going to want to review all of your quizzes and look at that information. That's the kind of stuff that for right now that I would be focused on. Going back, if you want to be reviewing stuff from the past, kind of have a working thing, a working review, I guess, with your quizzes, so that you can be memorizing the information that you're seeing on those quizzes. A lot of that information is going to be asked in your FAA practical exam setting. A lot of it you may see on the ADX exam as well. So if that, just to kind of, I guess, reiterate some of the day one, topics, is just, if you're worried about not getting it, or if you're worried about, what do I need to know, what do I not need to know, we can always obviously do a better job of reiterating what you need to do and what you need to learn and write down to memorize. But most of that stuff, if you hear Garrett or I say, you need to know this or write this down, if we preface any one of these topics with that, then yes, that's where you really need to pay the special attention to. And more than likely you're going to see that on a quiz, and more than likely that's going to be used as one of the main things at the end to tie it all together. So what our goal really is to give you the base foundation of the base things you need to know to be a dispatcher, to be hired on as a dispatcher. And then also know that even once you have your dispatcher's license, that really just means, you know the basics. That's really all it is. Is the basics. And when you go onto an airline, it's the individual airline's responsibility to take you from that point and teach you their specific things that are, I guess, their airline specific stuff. The problem with trying to really do more than just the basics in this class is that every airline, when you go to an airline, every single airline is uniquely different in the way they apply the rules and the way that they apply procedures. And so even though we try and kind of mimic a lot of the SkyWest procedures in this class, and we use a lot of their material as far as their aircraft, their procedures and systems and things like that, we try and for the most part leave any SkyWest specific application out of it, because we know that if you don't end up there, or if you end up going on somewhere else, it may be more confusing. So you have to kind of take that into consideration as well when you're once you get hired onto an airline, they take you from that point and kind of mold you into the kind of dispatchers that they are for that airline. So even the ones that, even if you went and worked at SkyWest for a few years and then moved on to a different airline, you're going to notice that you have to completely start over. Anytime you even transition from an airline to an airline, you'll end up starting over, because all of the procedures and systems and things like that are going to be just completely different than what you learned at whatever airline you were at previously. So just kind of remember that and know that as you go along in the course. We're just trying to lay the foundation of the basic things you need to know, the stuff that's going to get you through the practical, get you, ADX practical, basically get your dispatch license, and prepare you for an airline interview as well. So that's kind of the goal and the hopeful outcome of this class and that's kind of what you need to be looking at it as, is just the basic foundation of being a dispatcher. And like I said, most of that honestly gets tied together at the very end when you're doing your flight planning. And that's really when it starts to click and be a lot more comfortable. So does anybody that has any questions on any of that stuff kind of that I just was talking about?
Yeah. So so if I'm underage to the point where I can get my license yet until October, then are airlines kind of iffy about hiring people that went through the course earlier than 23, because what if they think that, oh, he learned it a long time ago or 8 months ago, he's probably forgotten it all by now. So do they look at that kind of stuff? Or
what I can say about that is yes, they do look at it. They don't. They only look at it from the standpoint of well, okay, well, how long has it been since you got your license and and are trying to get hired on? So they do wonder how fresh it'll be. However, that's what the interview is for. I mean, they're not going to not interview you over that, if that's kind of what you're asking. They're always going to give you the shot. They will maybe go into the interview concerned with the amount of time that has transpired between getting your license and doing an interview. But you can dispel all of that concern with your own, self-studying and keeping up on the topics and go in and just wow them in the interview. Garrett's brother, Drew, who works at SkyWest, went through this exact same program, except when we taught it at Salt Lake Community College. There was almost a year between him getting his license and actually interviewing at SkyWest. And I talked with Bill, who's the director of dispatch for SkyWest. That he brought that up to me as one of his main concerns about Garrett's brother, and he said it beforehand. He's like, I'm worried that there's been a lot of times, says we're going to interview him, but And then I remember, I talked to Garrett and I talked to Drew. I basically told Garrett to pass it along to Drew, that was one of their concerns and their worries, is that, but he went in and he wowed him in the interview and got the job. So, and that happens even in the last hiring that they did in October. There were several people that got hired in the class that Garrett's in. There were several people in that class that were from my class from last April. So it happens, and they know it, but it only limits it. It's only going to be a limiting factor if you allow it to be. That's basically all I'm trying to say.
Okay, so basically, the main gist of it is, after this course, you're suggesting that I just review it over and over and over again. That way, when I get my actual license and going in for an interview, I don't forget it after that.
So we, sorry, Adam, I just have something to say to that. So, going back to the example of my little brother, with that year gap between the actual course and him interviewing, he didn't necessarily just go over the broad spectrum of the course. There's been multiple times where I've been like, you guys have to memorize this. This is something that is a very common interview question, or this is, those things. When I say that, that's what you need to review prior to an interview. And we're going to, we'll take a comprehensive test at the end. And like Adam said, study these quizzes and memorize the information off of them, because those are not only for your practical, but a lot of times airlines, they ask the questions that are on your practical. I mean, it doesn't change that much. You need to stay fresh on some of the flight planning, or, and understanding how to do certain things. But as far as, the actual questions that you're going to get asked, they all come from, the questions we ask you guys in this class are the questions that they'll ask you at the interview. So as long as you're staying fresh and studying the questions that we've given you in the quiz or in the final test, or that you can remember from your practical, that's what you're going to be asked. And that's, when my brother interviewed for SkyWest, that's what he studied. He made flashcards, and he just sat there for an hour a day and would go through his flashcards. So
the one thing that's also nice is that I will always be able to give you the insight on the interview, and because I get the feedback, and I have a lot of conversations with Bill there at SkyWest. And obviously this course, is going to be more specific, and the advantage obviously is going to be for SkyWest. And so that's, so I mean, those of you that are, looking at other airlines, it still applies. I mean, I've talked to a lot of people that have been, hired on and interviewed at other airlines, as well as the fact that I have interviewed before I came on with the FAA. I had interviewed probably almost at every single airline as well. The interviews obviously change over time, but with going back with the SkyWest thing and being more specific there, I always get a lot of feedback, and I have after you get your license and stuff, we worry a little bit more about the specific interview questions. Once that's lined up, I have a whole document ready to go, to send you guys for like the interview preparation. But just to kind of give you an example, in the interview, they're going to ask you they're going to ask you questions about the FARs. You're going to get a few questions on the FARs, and the ones that are specific to the dispatchers, the ones that you need to have memorized as a dispatcher. Basically, you're probably going to get asked 2 or 3 or 4 questions on that. You're going to get asked probably a few questions on systems. You're going to be asked to read weather and be asked about weather and kind of give your feedback on different situations regarding weather. You're going to be asked, obviously your typical HR questions, which is, true of any interview you do, whether it's a dispatcher or not. But I mean, I have a whole document that, you'll be able to have access to and use to prepare. But the bottom line is that if you are knowledgeable enough to pass your practical exam and get your license, then this is going to be stuff that you would already know. The only difference is that, once you have the interview lined up and ready to go, I send out kind of more of the specific focus items just for the interview. And a lot of that, like I said, is based on my conversations that I have with the managers at SkyWest and the feedback they give me on the people from this class that interview, and the ones that get hired and the ones that don't. In the last class, I believe we had either 11 or 12 people interview, and 8 or 9 of them got hired. The ones that didn't, there's 2 or 3 that interviewed last time that didn't get hired, but they're looking to get hired on hopefully in the next round. And they're constantly emailing me back and forth to stay fresh, as well as the fact that they also have access to this class, and they can come in and they can refresh on the items that you need. You're going to notice once we get to the flight planning stage, you're going to probably see a couple of extra people in here that will jump in just to review on that specific part of it that are maybe from the previous class. So, and some of them are doing it for the interview prep. Some of them are, there's some students from previous classes that are still, for whatever reason didn't finish up their licensing, and whether it be family issues, medical issues, or whatever, that are now kind of circling back and doing it as well. So, but you'll have that option as well if needed, especially in your situation, Matt, where you have to wait no matter what, regardless of of whether you got hired on immediately or not. I mean, just the age factor. So in your case, you're just going to want to stay up, when we run the next class, sometime in the spring or summer, you're going to probably want to participate in those areas that you need refreshing on as well. And you'll be able to do that.
Yeah. And that's the great thing about this program is that, you can come back and you can continue even after this class asking me and Adam questions about, specifics or coming through and sitting and refreshing all of this information. And so, we're not going to leave you out stranded on an island, but yeah, kind of to get back to what we've been talking about with the CRJ aircraft. There's some really key points that we've gone over that I want you guys to take notes on, that we need to talk about. And Adam, I don't know if you have um, the list specific to the CRJ 700 that has all of its weights and operational differences and things. But if not, then we can get it on the Google Drive. But
Yeah,
there's
I'll work on. I'll go. I thought it was in there, but yeah, just carry on it. I'll go and make sure that it's in there, and then you can jump in and grab it here in just a second.
Yeah, so we're going to go over some weights that are very specific to the CRJ 700 aircraft. So I need you guys to focus here, to write this down, because it's possible that there's going to be stuff that I bring up when talking about this that is going to be in your test. And not only that, but you're going to have to remember when we start flight planning. So this part is really important to take notes on. Do you guys need like a 10-minute break before we get going on this, or are you guys good?
Please.
All right, let's take a 10-minute break. Let's just say 8:30.
Cool. Thank you.
Yep.
I'm like, oh, maybe.
So this is what we're going to go over now. So these are kind of the specifications of specific to the CRJ 700. This information is going to be, once again, in the Google Drive for you guys to look at. There are some very specific things that you guys need to make sure that you memorize and know and understand. So one thing that you guys need to know are these weights. The maximum ramp weight of the CRJ is that 75,250. The maximum takeoff weight is 75,000 pounds. The max landing weight is 67,000 pounds. The max zero fuel weight, you can see all of this. I'm not going to go through them one by one, but very important to know. You don't need to know the kilograms, but you do need to know these pounds. When we talk about the max ramp weight, that's the most that the aircraft can weigh with full fuel, full passengers, full baggage. Like, that's the most it can weigh when it's sitting on the ramp ready to taxi. You'll see a 250-pound difference between these two weights. The max takeoff weight, so they'll allow 250 pounds basically for taxiing purposes, but the most the aircraft can weigh when it pulls onto the runway is 75,000 pounds. A lot of times our aircraft aren't necessarily limited by the maximum takeoff weight so much, but more, well, I guess it depends on performance issues, but we see a lot of penalties and performance losses based on our maximum landing weight of the aircraft. So kind of a food for thought, kind of interesting. Something I didn't really realize prior to getting on with SkyWest, but this weight is extremely important. So this maximum landing weight, these two weights are extremely important in the fact that we can't even operate the flight if we're over our max takeoff weight, or if we're over our max landing weight at the end of the flight. So really important to know those weights, and along with that, to know how much fuel we can have on board. So this maximum zero fuel weight is basically the aircraft with the passengers on board. So passengers and cargo on board. We'll do weight and balance probably tomorrow, but you guys will see why these weights are important. But the zero fuel weight is the weight of the aircraft with passengers and cargo on board, and then we add the fuel. And the most fuel we can have on board is 19,450 pounds. So, yeah. Our normal cruise speed is Mach 0.78. This is what we'll use in our flight planning. Let's see. Let's pick out some more of these important specifications. So here's our average cruise per. I believe that's so off. So when we're averaging our fuel, when we're doing our flight planning, there's specific fuel burns that we're gonna kind of use to help us get a ballpark figure as far as how much fuel we're gonna need for our flight. I'll tell you right now, it's not going to be that 444 gallons.
Hey Garrett, are you talking about like the
pounds?
Total pounds of the cruise
Yeah,
average?
that's. I guess that. Yeah, when you try, let's see what that is in pounds. What is it?
Just remember on here, most of this stuff is just for informational purposes. Like,
yeah,
thing that you guys really need to know on this sheet are really just the weights at the very top, and even furthermore, really just the max ramp weight, the max takeoff weight, the max landing weight, and the max zero fuel weight. The other ones are good to know, like for instance, the max fuel load, that's good to know. The rest of them, you don't, those four highlighted are the ones you need to have memorized, absolutely, for sure. The rest of them, you don't necessarily need to have memorized. They're good to know. They're just as a reference item, so in case you ever needed it for any reason. But those four at the top, those play a factor in every single flight that you flight plan. And that's why you need to have them memorized, because every flight that you dispatch, and especially later on when you get into the manual flight planning, they're going to play a role in every single flight you do. The other information may or may not. The rest of this is just kind of more informational, just kind of a, wow, I didn't know that, or, just to kind of show you kind of just the specs of the aircraft. But those four weights at the top are the things that you really need to have memorized off of this sheet.
Yeah. So
there's a lot of other factors that come in, like the fuel load and things like that, or the fuel burn per hour. That can vary from flight to flight, simply just based on wind and the payload factor of the airplane and all sorts of different things. The rest of the information is really just kind of an average, and because it does vary quite a bit from flight to flight, on just depending on the altitude that you're at, the payload on the aircraft, and several other things. So,
yeah. So, just for kicks and giggles, I was wrong. 444 gallons an hour is right. It's pretty close to our average, but Not
One thing that you guys
necessarily
are going to notice
important, but
too is
What did you
just
say it
one thing.
was?
I was just saying that it comes out to about 3,500 pounds an hour, which is about the general average that we use when we're doing our flight plans, but it's not something that you have to have memorized. So
Oh, okay.
Yeah,
Sorry.
and one thing too, that just so everybody knows, is that when you get into the aircraft environment, you will never use when you're talking about fuel, you will never use gallons. So it'll always everything will always be in pounds. So you're going to put 5,000 pounds of fuel. So everything is going to be pounds. The weight of the aircraft in pounds, the baggage weight, the passenger weights, the fuel weight, everything will be pounds. So, and it's really just to help simplify. So just remember 1 gallon is roughly 6.7 pounds. So if you ever want to just do a quick conversion factor, if somebody's, for whatever reason, a station calls you up and says, how many gallons? Even those guys go in pounds. So, but just like, for instance, I was on an airplane coming out to here to Oklahoma City the other day, and we actually diverted. We were flying from Louisville down to Dallas Fort Worth, and we diverted to Wichita. Anyway, we got fuel in Wichita, but the guy sitting next to me, we were looking out the window at the fuel truck, and because they were refueling, and he was like, wow, you wonder how many gallons of fuel that they use. And so we got into this big conversation just about like how many gallons it is and the pounds and all this stuff. But that's I was telling him, I was like, in the aviation world, you never really ever use gallons at all. It's all just in pounds. So just remember that pounds, 6.7 pounds to 1 gallon if you ever needed that. But everything will usually just be given to you in pounds.
that's why it threw me off. So sorry, I corrected myself. But some other important information that we kind of went over yesterday with the aircraft that you guys need to know and memorize are things like we talked a lot about the where we get our power, the sources of power. You guys remember what the sources of power are that are on the aircraft?
AC and DC power.
Well, not the types of power it produces, but what are the generators, the main power supplying?
APU.
APU is one of them. What's the other two?
IDG.
Okay. How many IDGs are on board?
2.
Okay. And then there's one more.
ADG.
Perfect. So yeah, it's really important to remember that we have 3 sources of power. We've got a primary, backup, or auxiliary power, and then an emergency source of power. Another thing that you guys need to make sure that you guys have memorized is how many hydraulic systems there are and how many pumps are on each system. So you guys remember that? We went over that like 6 times yesterday.
Isn't there 4 hydraulics?
Nope.
Or sorry,
3 hydraulic systems.
Yeah, 3 hydraulic systems. And how many pumps are on each system?
I'm gonna write this one down.
Yeah, 2. So yeah, I suggest you write all of this down. This is stuff that is kind of important. Not kind of important. It's very important.
All right, so there are 3 hydraulic systems, and there are 2 of what?
So there's 3 hydraulic systems, and there are 2 pumps in each system. Now, do you guys remember what those pumps do, or how many are engine driven, how many are electrically driven?
Hold on. Okay, going back.
So the hydraulic pumps are labeled, 1, 2, and 3. Or I mean, the systems are 1, 2, and 3, and then the two pumps inside those systems, you have a primary and a backup in each system. So they're labeled A and B, right? So our A is our primary, and B is the backup for each one of the systems. Now, if you guys remember, the ADG powers the 3B pump, which is that emergency pump. It basically, system 1 will power what is it? The left side of the aircraft. System 2 powers the right side of the aircraft, basically, as far as flight controls. Well, system 3 basically can power all the primary flight controls, and it's a backup to system 1 and 2, basically. So that's kind of stripping it down to the bare bones there. But speaking of primary flight controls, what are the 4 primary flight controls on the CRJ?
The ailerons, multifunctions, spoilerons, elevator, and rudder.
Perfect. Word for word, you nailed it.
Thank you.
Yeah. And so, again, that's super key to understand that and to have that memorized. I can't stress that enough. The primaries are what's basically allowing the aircraft to rotate on the 3 axes. So that's what's giving us our ability to control the airplane while in the air. So once again, those 4 primary flight controls are going to be your ailerons, multifunction spoilerons, your elevator, and rudder. So now when we talk about the wings and we talk about bleed air, these primary surfaces of the aircraft, what are the areas that are anti-iced using bleed air from the engines? Does anybody remember that?
What are the areas anti-ice?
It's the leading edge of
Wings?
just about everything. The wings, the vertical stabilizer, the engine inlet, cowl, etc.
Yeah. So the leading edge is the wings, right? And the engine cowls. So really critical surfaces that if ice forms on those surfaces, the plane's probably not going to be in the air for long.
Well, my question about that is, if if it's bad for an engine to intake the ice or anti-ice, how come? Or wouldn't you get it sprayed into the engine if you were to spray it onto the cowlings?
We're not talking about the anti-ice spray. We're talking about the heated surfaces of the engine. So when we turn on the engines, we'll take the heat from the 6th stage. If you guys remember that, what were the 2 stages that we took the bleed air from? You guys,
Wasn't it 6 and 8?
6th and 10th. So the 6th and the 10th, the 6 is providing our primary source of bleed air, right? And the 10th is a backup and basically helps the 6th stage when it can't supply enough. So that 6th stage is located in an area of the engine that gets extremely hot. And the bleed air runs from the 6th stage of the engines and runs out to those leading edges. Remember how on the aircraft you have those really high polished, almost chrome surfaces. Let's see. I'll pull up a picture of the aircraft again. So once again, these surfaces, we call these the critical surfaces of the aircraft. These leading edges, that bleed air comes off somewhere in this area of the engine, and it's piped to this engine cowling here, and then to these primary surfaces of the aircraft, these critical surfaces. And basically it just heats these areas up to pretty high temperatures. Like if you were to touch the leading edge of an aircraft when the anti-ice is on, you're probably going to get like second or third degree burns pretty quick. That air is extremely, extremely hot. It's like touching an iron, right? But yeah, so it's important to remember, we call it wing anti-ice and engine anti-ice. And when we say engine anti-ice, more specifically, it's the engine cowl. We don't anti-ice the actual inside of the engine because it's already hot enough, right? but we heat this outside area, the cowling of the engine. So once again, that bleed air is pulled off of the 6th and the 10th stage of the engine and basically supplied to these critical surfaces of the aircraft. So we talked about the APU and kind of the purpose of the APU already. You guys remember what are the two purposes or the primary functions of the APU?
The primary function is to operate as a backup generator.
Okay, great.
And second function is to supply bleed air from within air conditioning and engine starting.
Perfect. Yeah, so like we talked about even earlier today, when the aircraft gets down on the ground and when we were talking about MELs for the APU, when the aircraft gets on the ground, and kind of like what you relayed to us earlier, Matt, if the APU is out of service and or deferred is what we would say, if that APU is deferred, then if the pilot shuts down the aircraft and stops, basically turns off the engines, then we have to have that compressor cart and the start cart in order to fire the engines back up, because that APU is what actually supplies the bleed air for that engine start. So, anybody have any questions on any of that information? Does everybody understand it?
Yes, sir.
Yes, sir.
Okay. Those are like the really meat and potatoes of what you guys have to memorize, are those weights and what we just went over. The other information is all secondary and just kind of supports those ideas, and you'll begin to understand them when we're actually flight planning, like Adam said. But those, like, you have to know those systems that we just talked about, because it's not only important to our flight planning and like I said earlier today, the performance and the how the aircraft functions, but but also when you guys go and get into whatever airline you guys decide to get on with, a lot of these systems, they're going to change a little bit. There's going to be minor changes, but for the most part, you're going to have an APU or a backup power source. You're going to have IDGs. You're going to have, anti-ice. Like, these systems are critical for your understanding of how these aircraft work and perform. So, although sometimes the name changes or they're a little more technologically advanced, the basic function of these parts is going to be basically the same. I said, just as an example, I said that the ADG, we call it an ADG on the CRJ, but like on our ERJs, that little propeller that pops out on the side, we call it a ram air turbine. But they do identically the same job. It's a propeller that works just like a windmill, generating power and supplying energy to the hydraulic pump that powers the primary flight controls of the aircraft and the necessary electrical components of the cockpit. So that's why we go over systems. That's why you learn an aircraft in dispatch school, is because it's the basics. And like we talked about earlier today, when you go to an airline, they just teach you the specifics of their aircraft and how they work. So does anybody have any questions on this aircraft? I don't know. I could look at these all day.
Those are
All right. So just kind of for fun, we just got a couple more minutes. Well, I guess we have like a half an hour, but we've kind of beat the CRJ to death. Now, just for fun and for reference, and to kind of help you guys see some of the stuff that we talked about yesterday and today, you can kind of see some of the stuff that we had talked about with the systems. But when we see a landing gear configuration like this, that's why we call it a tricycle gear. You got your nose gear and then two main gear. If the wheel was back here on the back of the aircraft, we call it a tail dragger. But this right here, kind of another fun thing, is this is the emergency hatch for the cockpit. So this is the emergency egress for the pilot and co-pilot if there's an accident or they needed to get out of the aircraft. This right here, the very tip of the nose of the aircraft, that's called a radome. Underneath that little nose cone right there is the weather radar. We talked about the pitot tubes. This is the pitot tube, static ports. This is the inlet for the APU. The APU on the 700 is actually back here. I mean, it's back here on the CRJ 200s as well, but on the CRJ 700s, the exhaust, like we talked about yesterday, is a lot higher up. Whereas the CRJ 200, you're not allowed to. You don't want to be standing, in this aft FO side of the aircraft when that APU is running, or else you'll get cooked.
I should tell the pilots in that, because every time I'm fueling the airplane, when they're doing their walk around, I always see them just standing like 5 feet away just to get heated up. they just stand there and just kind of look around just so they can warm up real quick before they do the rest of the check, the walk around.
Yeah. So we
I mean,
call
it's effective.
yeah, we call that it's a safety zone that you're not technically supposed to be in that area when the APU is running. And you guys remember the flight we talked about with the icing the other day that crashed into the Potomac? What was that?
Are you talking about the one where the one plane flew up behind the other one to try to de-ice
Yeah,
the wings?
he was taxiing. Yeah, he was just taxiing, but he got right up next to the aircraft in front of him, which you're not supposed to do. To have it blow the ice off the aircraft.
How hot do those get temperature-wise?
I don't know.
Probably doesn't matter, but I'm just
Yeah,
curious.
no, I don't know an exact temperature, but let's just
if you
say,
look into it, it's glowing red.
yeah.
Like if you
Or like
stand out
red
there.
hot? Oh, okay.
Oh, yeah. All the rampers, we would stand around to stay warm on the ramp in Salt Lake in the winter, and dries out your gloves really fast. But if you're not careful, it dries them out and then heats them up.
Oh, goodness.
You're throwing your gloves on the ground, but no, we'd always use it to keep warm.
Yeah.
All right, okay.
Yeah, pretty good amount of heat. I mean, it's a turbine, right? It's a jet engine, but just a small one.
Right.
But yeah, it's crazy. Crazy how hot it can get. But these are just antennas for the different radios inside the aircraft. We also talked a lot about this strake. That is one way that you identify a 700 versus a 900 or 200. That strake, and then the single overwing exit. Yeah. I know in that video, it kind of talks about these the winglets. You guys remember that video talking about that we watched today, talking about those winglets and what they do? Maybe it didn't talk about the winglet itself, but it talked about the wingtip vortices. So, as an aircraft is flying through through the air, let's see if I can get a little different. Don't look. Let's see. Get a little bit better view of it. But anyway, so as the wings coming over the top and underneath, or the air's coming over the wing on the top and bottom, it's slowly like coming down the end of the wing here, and without these winglets, it basically it gets close enough to where it just starts spilling off, right? Basically, the wingtips are stalling at that point. Well, what they found is when they add this wingtip vortice, winglet. Oh my goodness! It prevents those wingtip vortices from actually forming on the end of the wings. So it doesn't really talk about it in that video very much, but the wingtip vortices will basically make a good portion of the end of the wing unusable. It's not really generating lift. So with this wingtip, just turning the wing up like that actually makes the effective area of the wing, say the ineffective part of the wing without it is right here. That winglet will actually make it completely effective all the way out to here. Kind of interesting, which helps with like fuel burns and everything. So Anyways,
I looked up red hot when you said that. I had to see. So metal turns red in between 1100 and 1200 degrees.
yeah, it's
So
pretty freaking hot.
yeah.
There's this um I just posted a video of I guess when after everyone's done or whatever. I don't take it off the topic, but I guess when everyone's done, they can check out a video. I just posted it. It's the CRJ talking pilots are like flying the cockpit. They're talking about how they're doing their job. It's really cool. Well, I sent it to you by accident, Garrett. I meant to send it to everybody.
Oh, let's see. There you go. Yeah. Well, do you guys have any questions about anything that we've gone over the last 2 days? I mean, you guys pretty much have covered all of the aircraft as far as systems and performance goes. We'll get into weight and balance tomorrow. We'll talk about doing weight and balance on the aircraft. So weight and balance is actually a lot of fun. I'll tell you guys this much as far as this training goes. We hit flight planning so hard in this class. That's why we're taking like the last 2 weeks off. And we're meeting together and going over flight planning. Is we hit it really hard, and you guys will get really good at flight planning. In the class of 20 dispatchers that I went through training with, there's a portion of the actual flight training or dispatch training that we do when we first get hired at SkyWest. We do a section just on flight planning, and we have to build routes on our tablets that they supply you with. And I was amazed. We have dispatchers from pretty much every school across the country: Sheffield Air, IFA, Jeppesen, all these big name schools, dispatch schools. And like the only ones that understood and could complete the flight planning really without a problem were the ones that have gone through this course. I was completely shocked when I saw so many people struggling with doing flight planning in the training. It's pretty comical almost. So that is one thing that you guys will walk away with is really good understanding of flight planning. And that's really where the rubber meets the road, right? So yeah. I guess I'll ask one more time. Any questions on the CRJ so far?
No, sir.
All right.
I don't have any questions per se. I was gonna run by what I like, just a quick like one over, and if I missed anything in my notes, could somebody maybe point something out?
Okay, yeah, that's fine.
If that's okay. I've got the auxiliary power unit stuff. I've got like the IDG stuff, the single pack operations, all of the different like flight controls, the first and secondary stuff, the fuel tank systems, and the flap systems, the V1, V2, and VRs, and the weights. Did I miss anything?
That sounds about right. Sounds like
Okay.
a lot of the main points
Oh,
that we hit tonight.
And I had the hydraulic systems and the amount of fuel that it carries. Okay, I was just making sure. Just want to make sure I got it all down.
Yeah.
Cool.
Anybody else have any questions or? All right. Well, I'll let you guys go about 20 minutes early tonight. So
Sweet.
yeah,
Thanks.
if you have any concerns or questions, just let Adam or I know. So
Yeah, is the quiz gonna be Monday again, or maybe Tuesday?
yeah, I'm pretty sure we'll be doing the quiz on Monday. We'll do a review tomorrow for the quiz. I think as far as going over doing a review twice on the quiz, like we have been doing, I think if we just do it once, I know you guys won't feel prepared, but that'll give me a better understanding of where I can improve. You know what I'm saying? So we'll do our review, and then we'll just plan on taking the quiz Monday, and we'll do a very thorough review once again, but we'll plan Monday for the quiz this time. So
Sounds good.
Sweet.
all right,
Garrett,
yeah.
Sounds like a plan.
are we gonna, and then, so I know that we're at week 3, which I'm really excited about. Are we gonna have a midterm? I just wanna like prepare myself. After like week 3, do we have a midterm and then a final, or do we,
No,
or am I jumping ahead?
no. You're not. So we don't really do a midterm. We just do
Okay,
we'll just do a final. Just our weekly quizzes are the review of the subjects that we've covered is all. So
okay, sounds great.
all right. Well, you guys have a good night, and we'll talk to you guys again tomorrow.
Cool. Thanks, Garrett.
Thank you.
Yep.
Yep.
Thanks.
Thanks, Garrett.
No problem.